Detection of functional group if no extra element is present. So we can detect this different type of functional group. So let us take this unsaturation test for the alkenes and alkynes. So we have, if you have been given one is alkene, one is alkyne, how you can detect this alkenes and alkyne? So we have one test called as unsaturation test. So in this test we are using three different type of reagent. One is Br2 in CCl4, second is Br2 in water, and third is alkaline KMnO4 solution, and this is also called as the Beer's reagent. So anyone, these three reagent can give you the identification between, not identification of the alkenes and alkynes both. So every three reagent can give alkenes and alkynes. So let us see these examples. This is an alkene. So on reaction with the bromine in CCl4, so this bromine in orange red color, it will convert into colorless. So addition of bromine is the anti-addition. So this color will be decolorizes. Similarly, if you take alkyne, so in presence of bromine, the color of the bromine is orange red. So in CCl4, this will again added, it becomes colorless because bromine is discharged. And on further breaking of this double bond, so this will becomes the vicinal tetrahalides, tetrabromides. So again the color of the bromine becomes colorless. So this is the test for alkenes and alkynes. So next we can use the KMnO4 solutions. So KMnO4 is the Beer's reagent. You can see this is the KMnO4 is the Beer's reagent. So this will also give the unsaturation test. So first, this is reacted with the water. So they will give you potassium hydroxide and MnO2 and nascent oxygen released. So this purple color of the KMnO4 is converted into brownish black color, which is the precipitate, and nascent oxygen released. This nascent oxygen can attack with the alkenes and alkynes. So let us see, this is the alkene. So on reaction with the nascent oxygen, this will becomes the colorless, but the color of the purple will become brownish black. So change of this color will identify the reaction is the substance or substrate is alkene or alkyne. Similarly, it can also react with the nascent oxygen with the alkyne. So we will get again oxalic acid. So this is a colorless solutions, but the color of the base reagent is changed to brownish black. So this will give you identification of unsaturated compounds, but we cannot identify which is alkene and which is alkyne. Among the alkyne, we have two different type of test. One is terminal alkyne and second is non-terminal alkyne. So we can distinguish between terminal and non-terminal alkyne. So terminal alkyne test is given by Tollens or Benedict solution. So this is two reagents are there. So from this or failing solutions, so this three reagent we can identify the terminal alkyne. So let us see this one. Tollens reagents are actually, it is the not commercially available. Why? Because it's a short life, it has very small shelf life. So it should be prepared in the laboratory. And one more important thing is that if you keep this Tollens reagent for a long time, so it becomes explosive. That's why this is a freshly prepared. So when terminal alkynes react with Tollens reagent, so this Tollens reagent will give a silver mirror white test, white precipitate. So let us see this reaction. This is a silver nitrate aqueous solution on reaction with sodium hydroxide. It will give you silver oxide. It is a brown solid. It is brown in color, and this brown color will react with the actually ammonia solutions in sodium nitrate. So this will become a silver ammonical solution, silver aqua complex. This aqua complex actually reacting with the terminal hydrogen because this is a mild oxidizing agent. So they will remove the hydrogen and we will get finally a white precipitate of silver alkylinite. So this only terminal alkyne can react with the Tollens reagent. So next is the Benedict solution. So Benedict solutions is actually copper sulfate solution, aqua copper solution, which is also called the failing solutions. And in presence of ammonia, aqueous ammonia, so it will give you this Benedict solution. So this is a complex solution of copper sulfate in which the copper 2, this copper 2 is the active ingredient, and which will participate in the reaction of terminal alkynes. So this is the one example of terminal alkynes. So this is again, it is not a failing solution, it is actually the Benedict solutions. So you can write here Benedict solutions. So on the reaction of this Benedict solution, it will convert into copper alkalinide, and this will give you reddish precipitate or some reddish brown precipitate like this. So only terminal alkyne can give these reactions. If you take any non-terminal alkynes, they will not react with the Benedict solutions or any Tollens reagent. So they will not give any test.